In this example, we're given a solid liquid phase diagram for a magnesium silicon system. And it says we start with 1 mole of liquid and the silicon mole fraction is 0.8. So that means we're up at high enough temperature, somewhere around here, mole fraction of 0.8. And then we're going to cool this down until we have 0.2 of a mole of liquid, and we want to know when that happens what phases we have, how much of each of those phases. So when we reach this temperature, we start to see solid silicon forming, and as we continue to lower the temperature, we get more solid silicon, and of course the composition, the mole fraction in the liquid changes because we're removing just silicon. When we reach this line, it's about 1220 Kelvin. Well, we have now solid silicon in equilibrium with the liquid, and the mole fraction of silicon in that liquid is about 0.52, just reading off the x-axis. Well, if I look at this is not quite in the center, but we're close to that. We say approximately we have half a mole of each. Maybe we have 0.6 of a mole of silicon, but we don't have just 0.2 of a mole of liquid yet, so we're going to have to continue to remove heat, but now the temperature doesn't change. And as we do that, we start forming silicon, and we form this compound. Its mole fraction of silicon is 0.33, therefore its mole fraction of magnesium is 0.67. So magnesium is twice silicon. So now we have 3 phases. We have the liquid with this composition of 0.52. We have solid silicon, and we have solid Mg2Si. And so what we're going to do are mass balances. The amount of liquid plus the amount of solid silicon plus the amount of the compound must add up to the 1 mole that we started with. And we can also do balance on the Mg. So the mole fraction of Mg in the liquid phase times the number of moles of liquid plus the mole fraction of Mg, and let's use this terminology, that's in the liquid phase. And this is the mole fraction of Mg in the solid phase. So the mole fraction of magnesium in the solid phase, the compound, times the number of moles of the solid, Mg2Si, has to be a number of moles of magnesium that we started with. Well, we had total 1 mole and 80% was silicon, so only 20% or 0.02 moles were magnesium. Well, the mole fraction in the liquid phase for magnesium is 0.52 for silicon, so it's 0.48 for magnesium, and we said we have 0.2 moles. And now the mole fraction of magnesium in the compound is 0.67, right, since the mole fraction of silicon is 0.33, and the number of moles is what we're trying to solve for, 0.20 moles. This from number of moles of the compound, we get 0.155 moles. So it means now if we go back to the overall mass balance, 0.2 of a mole of liquid plus number of moles of elemental silicon, that's what we want to determine, plus the 0.155 moles. That must add up to the 1 mole that we started with, so the number of moles of elemental silicon then 0.645 moles. So we've identified number of moles of silicon compound plus the number of moles of liquid that we started with at 0.2.